Hello folks, in this video we'll see how to solve the maximal rectangle problem, which is a hard problem on LeetCode. So we'll be given a binary matrix like this, and from this binary matrix we have to find the rectangle with largest area. Okay, the rectangle containing only ones. Okay, so how we can solve this problem? Previously in one of the problems we have seen how to find out the rectangle with maximum area from a histogram, right? So from this binary matrix, if we are able to make out a histogram, then we can find out the answer the same way, right? So what we can do is, from this binary matrix we can consider one row at a time. Okay, one row at first, then we can consider two rows, then we can consider three rows. Likewise, we can consider all the n rows at last. Okay, so when we consider a combination of rows in order, okay, we'll be considering rows in order. First we'll take one, then two, then three, likewise. Okay, so during each step we'll be taking rows from this binary matrix and we'll be converting it into a histogram. Okay, from that histogram we'll find out the rectangle with maximum area. Okay, now that is something we have already done in one of the previous problem. So if you want a detailed explanation on that, you can watch that video. You must watch that video to understand how we are calculating maximum area from a histogram. Okay, so we'll be using that particular code in this solution along with a few extra things. Okay, so what we can do is, first we can consider one row from this binary matrix and convert it into a histogram, and from that histogram we'll find out the maximum rectangle possible. Okay, after that we'll consider two rows together and we'll convert it into a histogram, and same way we'll try to find out the maximum rectangle from that. Okay, so like that we'll repeat till at last we'll be considering all the rows together and converting it into a histogram, and we'll find out the maximum rectangle possible. Okay, so somewhere along our iteration, okay, at some point, we don't know, in some cases maybe when we were considering 3 or 4 or when we were considering some amount of rows together, some number of rows together, we may get a maximum rectangle. Okay, this rectangle can appear anywhere in the binary matrix. Okay, that's why we are considering that's why we are generating histograms like this and trying to find the rectangle with maximum area. Okay, and one thing to note here is, when we are converting this binary matrix into a histogram, there can be cases where 0 comes in, right? So when a 0 appears in a column, that means everything above that 0 can be ignored, right? Because when we say histogram means all the columns must be touching the bottom line of the histogram, right? If it is floating above, we cannot consider that as a histogram, right? So one thing to note here is, if at all we encounter a 0 while generating histogram, all the values, all the height of the column we have calculated so far can be ignored, okay, for that particular column, because the height or the column should not be floating above. Okay, it should be touching to the bottom level of histogram. Okay, so with that, let's start coding. First we can have first we can start with let's say we are given a binary matrix, right? So from matrix we can take the number of rows first. Okay, so rows equals len of matrix, right? So that gives number of rows in that matrix. Okay, in that given matrix. Now as I said, we'll be first considering one row, then we'll consider two rows. Likewise, we'll be keep on adding number of rows till at last we consider all the rows together, okay, to generate a histogram. Okay, so we'll be generating different histograms, and from each histograms we'll be trying to find out a rectangle with maximum area. Okay, so we'll use a for loop for that. So for I in range rows, I think we can call this R. For R in range rows, what we can do is we can use a variable to store the final result here. So max area equal to 0. Let it be 0 initially. Here we can write max area equal to max of max area, or here we have to find out the result. Okay, we have to generate a histogram and find the maximum rectangle we can find from that histogram. Okay, so I think we can write a separate function for that, for finding the histogram and finding the area, finding the maximum area. Okay, so what we can do is we can write a function definition here. Let it be get histo area. Okay, get histo area, and to this we'll be passing the combination of rows. Okay, let it be rows. We can come to this later. Let it be there. So here we'll call that function get histo area of. To this function we need to pass rows, right? So we have to pass matrix of 0 till the current index we are iterating. Okay, that is R, right? So what this does is during the first iteration it will send the first row. During the second iteration it will send 2 rows together, the top 2 rows. Okay, during the third iteration it will send 3 rows together. Okay, so as we complete these iterations, at last we'll be sending all the rows together, and among these result there will be a maximum rectangle, right? So we'll take that. So at last, after the loop, what we can do is we can return max area, right? That will be the result. Okay, so now let's go to this function get histogram area. Okay, so in this function what we'll be doing is we'll be generating histogram, okay, from the rows. Here we have rows as a parameter, so from rows we'll generate a histogram. Okay, so let it be histogram equals 0 into what is the length of histogram. That is, if a row has C columns, then this histogram should have C columns, right? So I think we can type cols equal to len of rows of 0, right? So we know the number of columns here, so we can initialize an array of length cols and set all the values to 0 initially. Okay, histogram. Now what we can do is we have to add up, right? This is a binary matrix, so there will be 1 and zeros, right? So to this histogram array, we are generating a histogram here, so we have to add the rows, right? We'll first take one row, and if there is one, we'll add that. Okay, so as we iterate through all the rows, we'll build up this histogram. Okay, at last we'll have the one single array which can be represented as a histogram. Okay, so we can use a for loop here for row in rows. We can say for call in range calls, right? We need to we'll have to do the addition for all the columns, right? So for call in range of calls, what we can do is histogram of call equal to if it is from the row, we can say if it is 0, what does that mean? As I mentioned before, if it is 0, that means there is a 0 coming in between. That means if at all there were ones above that row, all that can be avoided, or we can discard that, right? Because when a 0 comes in, that means there is a gap in between the column. That is in the middle of a column, in somewhere in the middle of column there is a gap. That is some value is floating, okay, not touching the ground level of histogram, bottom level of histogram, right? So we can ignore a previously calculated value there. That is, we can directly set 0 there. That is histogram of col equal to 0 if row of col equal to 0, right? If it is 0, that it can be directly 0, right? Else what can we do? Else we can add, this is a binary matrix, right? So if it is not 0, then it will be 1, right? We can add that 1 plus the already existing value. Okay, so we are just trying to increase the height of the column, okay, as we go. If it is 0, then that is not possible, like on the values on top of that will be avoided. If it is 1, we can add that, okay, and try to reach to the bottom, okay. So here 1 plus the previous value, histogram of col, okay. Now that is done. So at last, after this nested for loop, we'll be having a single variable histogram which can be represented as a histogram, okay. So so once we so since we have found out the histogram, what we have to do is we need to find the rectangle with maximum area from this histogram. This is something we have already discussed in one of the previous problems. So I request you to go through that video and understand in detail how we are solving that, okay. So the same logic will be used here, same code will be used here, okay. So what we can do here is we can return the rectangle area, maximum rectangle area, right? We are going to find. So for that also we can write a separate function, okay. Let's say, let it be def get max area histo, okay. So to this we'll be passing histogram, okay. We can come to that later. So we'll be returning that get max area histo of histogram, right? So here we have found out the histogram that we'll be passing to this function get max area histogram, where we'll be finding the maximum rectangle area possible, okay. So here whatever I'm writing is something we have discussed before, so please go through that video, okay, to understand it better. I'll be just writing the logic here, okay. So n equal to len of histogram, that is we are taking the length of the histogram first. Then what we can do is we need to find the left to how long it can be extended towards left and towards right, okay. We need to find the width, okay. Height we have, now we need to find the how much we can extend, okay. So for that we need two array, left limit equal to 0 into n and right limit equal to 0 into n, okay. We have two arrays for storing the information, like till which index it can extend towards left and right, and for the first element and last element it cannot extend towards left and right respectively. So for that scenario we can store here left limit of 0 equals 0 minus 1 and right limit of n minus 1, that is for the last element will be n, okay. The limiting index will be n for the last element. Now after that we need, for all the elements we need to find the limiting indexes, right? So for that we can use a for loop for I in range 1 to n. What we can do is we can use a pointer equal to I minus 1 initially. Let it start with the first element, okay. So while we can say the histogram, right? Histogram of pointer is greater than or equal to histogram of I, that is if the neighbor on the left side is greater than or equal to the element under consideration, then in that case we can say this element can be extended towards left. Okay, and also one more check we have to do is we should not, it should not result in index out of bounds error, right? So while pointer is greater than or equal to 0, okay, and this, okay, so during this we can update the pointer to the neighbor's result. Okay, that will be left limit of pointer, right? Left limit of pointer. Okay, after this while loop we'll have the result for the left limiting index. Okay, so we can say left limit of I equals pointer. Okay, similarly we can write the for loop for finding out the right limit as well. So in here we'll be moving from right to left backwards. Okay, and -2 till 0th index we'll be going in backward direction. Okay, and here we can write the same logic, pointer equal to I plus 1, let it be at the last index first, then while pointer is less than n and histogram of pointer is greater than or equal to histogram of I, in that case what we can do is we can update the pointer to that right neighbor's value, already calculated value. Okay, we are speeding up things by doing this. Okay, so that will be right limit of pointer. At last we can assign the result to right limit of I equals pointer. Now by this we have found out the left limiting index and right limiting index, that is we have found the width of the histogram element, okay, element under consideration. Now for all the elements we have found the width also. We were already knowing height, like in this function get histo area we were finding height, right, till what extent it the column can expand above the bottom level, right? So we were finding height in this function, and now here we have found out the width also. Now what we can do is we can loop through all the elements of histogram and we can find out the area, the rectangle with maximum area. Okay, so for that we can use a for loop again for I in range, and what we can do is height is histogram of I, right, and width is right limit of I minus left limit of I minus 1. That will give the exact width. Now the area will be height into width, right? So here again we need one variable to store the maximum area, max histo area equal to 0, let it be 0 initially. So we can say max histo area equal to max of max histo area or the currently calculated height into width. Okay, so at last we will be returning that result, that is return max histo area. Now during each iteration, during each combination of rows we'll be calling this function and we'll be finding max area, rectangle with maximum area from the histogram. Okay, so at last ultimately this result will be coming here, right, to the calling function, that is here max, that is the result will be stored to max area, right? So after all the loopings, like after considering 1, 2, 3 and etc., like considering all the rows together and generating a histogram and finding a rectangle with maximum area, the max area variable will be having the final result. Okay, so somewhere in the binary matrix there would have been a, there is a rectangle, okay, with maximum area. So that will be stored in max area variable that will return at last. So let's try running this. Okay. There is some error. Index less than line 32. Yeah, sorry. Actually, I wrote something wrong here. It should be r plus 1, right? Because the end index is exclusive, right? Yeah, so here r plus 1 then. And one more thing we can do is, if at all a number of rows, that is a number of rows is less than 1, that is we are given an input array with no rows, that is an empty input array, we can return 0 directly, right? We need not go further, right? So what we can do is we can write a condition: if rows less than 1, return 0. Okay, so let's try running it again. Yeah, it's working. See you in the next video.